I'm talking about extending the flexibility of a laboratory management application through an application program interface. So I'm looking at some STEM laboratories in the subjects of computer networking and cybersecurity mainly, but also the laboratories that we use are used by other computing subjects as well. So the components of a typical laboratory would obviously be laboratory computers, and we would need to use various operating systems. So we would use virtual machines to virtualize those. They may be Linux or Windows. And of course, being a networking laboratory, would also need to use network devices such as routers and switches. We're a Cisco Academy, so we mainly use Cisco routers and switches. But we also use simulators such as GNS3 or Packet Tracer. Now, we also have a management server. Any laboratory needs to be managed, and we need a management server. Now, when we look at configuration management, that's looking at obviously setting up the laboratory and making changes between sessions. We face quite a number of changes. So looking at configuration management, obviously there'll be quite a lot of variations in the requirements and configurations between different courses and different subjects. And obviously that would be based upon modules. So, for example, if we're teaching cybersecurity, perhaps we might be using Kali Linux and Metasploit. Whereas within other subjects, we may be using a Windows Server operating system, or we may be using, as I do, Ubuntu Linux. And they need to be configured with various configurations. We may need to use, say, Ansible or Docker or software-defined networks within those operating systems. And of course, the other thing is that let me turn my speakers down a bit. A bit of an echo there. So obviously we're also needing to communicate with routers and switches, as I said, and the problem is that there are often some of those requirements between different modules. There's a lot of conflict between them, so you may be having to set things up for one module and then a completely different configuration for another module. And then the question is, do we preserve data between the modules? So, for example, if we have multiple groups for a particular module, if the students have configured a system in one module, and then there's another group for the same module, and the students come along and they find that the previous group has already set the system up, obviously that's a problem. So we obviously need to perhaps return the system back to some baseline image. But we may need to just configure the systems. We may need to install new software or just reconfigure things without having to wipe the system completely, which is unlike a business, a commercial network where it's obviously important to preserve data, and configuration management is about making changes rather than replacing systems. So the solutions that we would need for this are, we need a configuration management solution, and it's likely that we'll need a cloning solution as well to rebuild the computers to a default state. So there are tools available for this, obviously. So we could use scripts. We could use PowerShell scripts for Windows. This can also be used in Linux now because PowerShell is available for Linux. We could also use Bash shell if we're using Linux systems, but also if we install Cygwin, we can use Bash within Windows systems as well. And we have used PowerShell scripts, a whole lot of PowerShell scripts in the past, but they tend to become unmanageable unless you've got some sort of management solution in place. So we could use a configuration management solution such as Ansible, which is one of the most popular ones at the moment, or we could use Puppet or Chef. With Ansible, you might need to put together quite a complicated playbook in the YAML data format. This is not something that perhaps can be done on a daily basis. You need to, if you're making constant changes, you may need several playbooks. So it gets a bit complicated. Then there is something called Ansible Tower, so that's a possibility to use that. For a cloning solution, well, you could use Semantic Go Solution Suite. We did use that for some time in the past. We also investigated Clonezilla, but we prefer it in the end, the free open source Ghost or Fog project, because obviously it's open source and it works on Linux. So what we end up with our management server is that we've got an Ubuntu server, and we're running a Windows server virtual machine, which is running our dynamic host configuration protocol DHCP server, which allocates addresses to the hosts in the laboratory. But we also developed a configuration management solution, an in-house one called Server Console. Now, this has been used for a number of years. It is used to simplify the configuration management of the laboratory. So it's basically a click and just a simple click of buttons to do a lot of various configuration management tasks rather than having to do any scripting. And the cloning solution that we chose, as I said, was Fog Server. So we're running Fog Server in Ubuntu. The Server Console application was developed in Visual Studio.NET in the C# language. It features a graphical user interface. It's used for configuration management, so that's for making changes to systems and also for doing things like installing software and a range of other things. And you can basically just select the target hosts and then send the whatever you want to those hosts, the configuration you want to those hosts. It manages PowerShell scripts. We ended up with a lot of PowerShell scripts, and these have now been incorporated in this configuration management application, and they're called from within this graphical interface. So this is what it looks like, fairly basic approach, but it needs to be simple so that we can just basically click and go. So for example, we can shut down the PCs, restart them. We can rebuild the virtual machines remotely. We can install software. We can transfer folders. We can set the IPs on things like the loopback interfaces. We could also change the IPs on the virtual machines. We can change passwords remotely and add new users remotely. We've also got a range of scripts so that you can actually create new scripts and then send those to the target hosts. And over on the right-hand side, you just select the host that you want to target, and obviously you apply the appropriate configuration to them. So with the cloning solution, we use, as I say, free open source Ghost or Fog project. It's got a web interface of its own, and basically you clone a host. You capture the image from a host and then you store the image. And then you can deploy those images to other hosts. You can do that to a single host using unicasting or multicasting if you're sending it to more than one host. But it does have an application program interface. One aspect of that is there's a PowerShell API, but there's also a REST API as well, which is web-based. Now, this is the Fog web interface. This is what it looks like. So, for example, in this example here, we're ready to send an image. So we've got active tasks, which the tasks involve sending an image to hosts in the laboratory. And what we looked at was to extend the server console to add a Fog extension to this. We looked at using the RESTful API, and there is in Visual Studio C#, there's a library called REST Sharp. Authentication for the API is via a Fog API token that can be extracted from the Fog server, and also a user token. And the requirements of this new extension were to display a list of fog images, also the hosts that are going to be the target of the imaging process. And we want to create tasks and check the progress of those tasks as well. That's the imaging tasks. So we need to allow the selection of an image, the target disk, and the target hosts. We also want to allow the creation, editing, and deletion of images, also fog hosts, and also the deployment task. So we want to stop a task. We want to be able to either we want to be able to obviously cancel that. And tasks must consist of either a creation of a new disk or partition image from a single host. That's a capture from a host, or deployment of an existing image to potentially one or more computers in the laboratory using unicasting or multicasting. We needed to test the API first of all to make sure that it worked. The simplest test would be to get an image, an existing image from the fog server, and we use curl to do that, and that's the syntax you can see there. Now, translating that into C# using the REST sharp library, as you can see, that's the same code there translated to C#. So in order to create a fog task, REST sharp will talk to the fog API. We create a fog task by selecting an image. We select target disk. We select host from the list over on the right-hand side. And then we either select a button to start an image deployment, having selected unicasting or multicasting, or we can select a button to capture the image from a single host. So this is what the server console fog extension looks like. You can see you can select the image over on the left. There's a target disk. So if there's more than one disk in the systems, then you can select the target disk there. And obviously you can select the mode of multicasting or unicasting. You select the target PCs over on the right-hand side, and you could also capture from a single PC as well. There's also a debug window, which helps us to do some troubleshooting. So in order to create a fog task, this is the C# code for that. So we need to edit each host to set the image using a put request, and then we post a new imaging task to each host. And that's done as from the list, so we can do it to multiple hosts. And then we can monitor active fog tasks. So here you see that we're trying to deploy an eDrive image to a number of hosts in the laboratory. And at the moment, we've got one host that's connected, and there's a progress. It's up to 42%. And you can see the debug window for troubleshooting as well. So that's the extension that we've got in this application. So testing, well, we had to test this. So we had to be able to create a host, first of all, create an image, edit the image, capture an image task, and then monitor the progress of that task. And we needed to be able to monitor the deployment of the image, whether either that's using unicasting or multicasting. And also we needed to be able to delete the task, and also to be able to delete an image, and also to delete a host. And we were able to do, eventually we're able to do all of those things successfully. So the results, well, in the fog web interface, there are 17 steps to start the deployment of an image to hosts in the laboratory, and you have to go to more than one page to do this, so it does take a bit of time to set up. Although, of course, the imaging for both methods will take the same. But we compared this to the server console, and we only need 6 steps to start the deployment, and this can be done from a single page. So there's a bit of time saved there, and a bit of complexity saved as well in this process. The time to deploy the image is the same because we're obviously using the fog engine for both. So in conclusion, the fog extension, this improved the flexibility of our server console application, and it was about reducing the complexity so we can just basically make it easier for people to deploy an image rather than having to go through several pages to deploy the image. And rather than having two interfaces to work with, we wanted to put this into a centralized interface. This is also part of a feasibility exercise, investigating how we can use third-party APIs within an existing application. And there's further work that we're investigating with this because we saw that we want to do the same kind of thing with software-defined networks. And so we're investigating that at the moment. And these are my references. And if there are any further questions, I can take those questions. I could even do a live demo if we've got time to do that. I'll just take you through to, hopefully hopefully you can still, I'm not sure if you can still see that actually.
Yes, we can, together with the
right.
side
Can you
ones.
see the laboratory there?
No, we're just seeing the
Okay.
slides.
Okay, right. It doesn't look as if it's going to let me go through to the laboratory then. It's not going to let me share that, but I've sort of got, I can go live through to our remote into our laboratory where it's kind of working at the moment, but obviously that doesn't seem to be appearing under the sharing for some reason, so I don't know why that is. So I'll just take questions in. Let me just have a look at the chat.
Thanks, Neville. I posted one first. I was curious. It sounds really a good approach you have. We're looking at something similar, but have you had any issues with your campus IT and getting permission to get these things working? We're trying to get permission to do some cybersecurity courses, but our campus IT, you're trying to get cyber essentials certification on campus. So we're trying to lock down everything we can. And I'm very unhappy if we want to do things like probe devices for security holes. So have you had any experiences of that, or is yours kind of closed off because of the way you configure it?
Yeah, we've got our own lab, so they tend to leave that to us. So ours is closed off, so we're not connected to the outside world. Well, there is a limited connectivity. We've got a whitelist in the firewall that allows us to access certain websites such as Ubuntu.com or Docker and Ansible and things like, and the Windows updates. So we have got remote access to the lab that are available for staff at the moment. We can actually make that available for students. We had to during the pandemic, but we don't do that at the moment. So they tend to leave it up to us, really. We have limited sort of IT support staff support. I think part of the reason is that I think due to the complexity, it tends to be down to, the academic staff to set things up. So we've tended to sort of prefer to do things ourselves because, as you say, the problem is that you go through the bureaucracy of a university, the ICT department in the university, and things tend not to get done. So they've tended to allow us to get on with it and do it ourselves. It does create extra work for us, but I suppose the idea of using the server console app is that we've got a simple to use interface, which is just point and click.
I guess a follow-up then on that is this something is it shared anywhere? Is it something on Git or somewhere, or is it something you could share with places? Or is
But it is on Git, but it's kind of it's a private Git project at the moment. I suppose it's customized for our lab, so it would need. I think it was used out elsewhere. It would probably need some customization.
Okay, thank you. Any other questions then, either in the meeting chat or if people want to unmute themselves?
Well, could I raise a question? Do you see that the model that you've got at Solent working, successfully in other universities?
Well, I think so. I mean, I think it's probably good to have, as you say, as Neil was saying there, that it's good to have a situation where you've got control over. If you're teaching cybersecurity, it's good to have your own control over it. I think it's a pity that we could do with more technician support. I think that would be definitely useful. But when it comes to cybersecurity and networking, really, I think the academics should have control of that. They should have the say, or somebody, if we want things done, we need it to be done, and we need it to be done usually now. That's a problem that if you go through ICT at a university, it can take a long time, and there's also a lot of security implications as well, and they don't like, you know. The security is really tied down in a university, isn't it, these days?
Thank you. Oh, could you unshare, by the way?
Oh, sure, yeah.
Have you any thoughts about where this might go to, looking much more long term? I mean,
Um, well, we're sort of making some enhancements at the moment. We had to. I mean, the reason we've sort of updated this is we've been given some money to install some new upgrade the laboratory. So they've got new computers, and we've actually got 4 laboratories that this will cover. So and we've been monitoring some of the problems some of the issues that we've been having. So uh, as obviously those issues arise, we can add more scripts and more functionality to this. One thing was about scheduling. So we want to be able to schedule access to the computers in the laboratory, for example. Also, we had an issue with being able to uh, with the interfaces tend to get clogged up with various protocols, and some of those can obviously conflict and stop function. Even being able to ping a router, we had the other day, that was a problem. So we added a module to this that enables us to remotely disable some of the protocols on interfaces. So that's the kind of thing. So as we go along, we add bits to it. And at the moment, we're covering 2 laboratories, but there'll be 2 more laboratories coming on after Christmas. That they will have a different set of requirements again. So I guess this will also need some further development.